All right, so to set up, you can go to lecture materials. Again, the link for that is in the notes below. Grab the notes for ANSYS of 2D heat transfer problems. And you can also get this SolidWorks file, chimney and heat sink parts. There's two parts in there that we're actually going to use, the chimney, the concrete part, and the brick part. There's another one in there that may or may not be used in a future example, but you'll get that. That's all in a zip file, so just unzip that and you'll be ready to go. All right, so now let's look at the ANSYS example. So we'll kind of see how this all works together, applying the boundary conditions. ANSYS, we don't have to really do the matrix math, so that's kind of nice. But we can do this work a little bit quicker and let the computer help us out here. So we're going to look at a couple different things here. If you want to skip to those things, the notes, feel free to look at that. But I'm going to take it step by step and hopefully get some extra tips here on how to use ANSYS and analyze different things there as well. So overall here we have some concrete interiors. So this is a cross section of our chimney. So we're looking essentially down the chimney in this case, or up the chimney. So we have concrete here, the initial 1 inch. And then we have our outer brick that goes 26 by 26 inches. And I've drawn these pieces again. They're in that zip file. If you can get it from the lecture materials, see the link below, and you can grab that and do this along with us. All right, so I'm going to go right over to SolidWorks that I already have open. And I'm going to create a new, this is a little bit different here because I already have the parts, but I'm going to create a new assembly, not a new part. So click on assembly here and OK. All right, so it asked which documents you want open, so I'm going to browse. And let's start with the concrete first. So I'll click on the concrete part and open. And if you bring it in here, you can see that you're there in the middle, right? And swing around. I don't want to just click anywhere, so I want to get it in the same spot because I want to line them up just right. And this is something I've done ahead of time, and we'll talk again more about later how to do this. But I'm just come up here and click on the green check mark because that's going to put it right at the origin. All right, so right at that spot there. All right, I want to add the brick now. So that's the concrete I want to add in the brick. So I'm going to come here to insert components and browse again and come back here and get the brick. So click and open and see there's the brick. So I would just put in here and I have to mate it and get it all in the right spot. I just want to get it. I'm not worried about that today. We'll talk about that later. So I just come in here and again green check mark. I put it right at the origin and it puts it in the exact spot I want it to be at on there. All right, so now we're ready to analyze this. That's all we really needed to do. So we could just take this right over to ANSYS and we'll go ahead and do that. So use my ANSYS integration here. And actually, I just realized I didn't save the part, so this is probably going to fail. So we'll just see what that failure looks like and go back and fix it here then. All right, so yeah, so it says right here, I don't know what geometry you're talking about. All right, so let's go back and do the SolidWorks here, and we're just going to go ahead and save this. And yep, save all. So it asked me what's my assembly name, and I'll just call it the chimney. And save. And now go back to ANSYS. I'm going to right click on geometry here. I need to left click there. Try right clicking again. Oh, that blew it up. All right, so it doesn't like that. Let's try it again from scratch here. Now that we've saved it. There we go. Selected that time. All right, so we want to do our analysis now, drag our analysis in. So we're going to do a steady state thermal analysis. We're looking at steady state here, so we're just going to click and drag it in. Drop it right in there. All right, so we have the geometry here. So we're going to drag it over and link those two. That looks good. Come back up here to engineering data. So double click on that. And obviously structural steel is not what we want. So we're going to need to come in here and go to the engineering data sources and find some stuff that's going to work for us here. So let's look at general materials first. Here you see what we come up with. And see, I think they have concrete here. Yep, there's concrete, so we'll add that. And see about brick. Do they have brick in here? Let's see it there. It's non-linear. We don't want to worry about that right now. Thermal materials. Yep. So they don't have brick, looks like. So what we're going to do is we're going to have to create a new one. All right, so let's go and get back to our materials here. So we're going to click right here. We're going to add new material. We're going to add brick. So just type it in there and hit enter. And it comes down here, and here are the properties for brick. All right, there aren't any because it hasn't been defined yet. So if I come over here to the left-hand side and expand thermal, I want to put in the isotropic thermal conductivity. All right, so I can add that in here, drag it down, drop it there. And so I can put in the value here. So from our sheet, though, we are in BTUs per hour, inch squared degree Fahrenheit. So BTUs per hour. We don't have inches, so we have feet squared per hour. So I'm going to do the second one here. All right. So we want to make sure we put in according to the units. So we got to go from, bring up the calculator here. So we have K for our brick is 0.04, and so that's per hour. And so we want to divide by, oh, I'm sorry, it was in feet, because it was feet issue, not inches. So we got to go from inches to feet. So we got 12 inches, so we want to multiply by 12 to get over to feet. So we got 0.48. So we'll go 0.48. All right, should be good there. All right, let's check out what concrete is. So concrete's 0.72. That's in, whoops, that's in watts. We don't want that. So we'll come down here and look at we have there. And to confirm, let's kind of back calc this one. We're going to go the other direction. So we'll do calculator here, and we got 0.41601. And that one's in feet, and we want to take it to inches, so we're going to divide by 12, and we get 0.03, which is not super close to the concrete, so maybe you want to update this one. We want this to be 0.07. All right, so let's fix that. So 0.07, that's in per inch, so again, multiply by 12, so that's 84. Okay, so let's update this to 84. Oops, 0.84. All right, so that looks like we should be good there. All right, so let's check our brick, 0.48. That's good, and then our concrete is 0.84. All right, so we got those. Let's go back now, so we can just go ahead and close that and go into our model. Double click there. All right, that looks good. So let's apply materials. Here we're going to just work our way down the left-hand side here. So geometry. We got the concrete. So concrete comes down here with the material assignment. Make sure we're on concrete. There we are. So that looks good. Go to chimney, brick. Change the assignment over to brick. That looks good. And you can check and see it's still concrete, still brick. All right, so we're not worried about meshing quite yet. Let's get the boundary conditions applied. So we just have convection on the outside, and we have convection on the inside. And this just is insulated here. This is basically just a cross-section slice, so we'll just keep this as insulated. And so it's just convection on the inside and the outside. And so let's go into thermal, so we can get convection. Up here is our boundary conditions, so thermal boundary conditions here. And so we're going to play it on the outside first, so we get click surface. And you see how we can't click more than one surface by just clicking. So I'm going to hold down Control, and so I can click more than one surface, and I'll just rotate it around to click these other two. And then I'm going to hit Apply. All right. And we got the film coefficient. So this is nice because look, it's in BTUs per second inches squared Fahrenheit, which is what we have from our, at least on our handout on the outside. So outside surface is 0.01, sorry, 0.012 BTUs per hour. Oh, now it's in seconds. Of course, everything keeps switching on us. I thought it was quite. All right, so it was an hour, this is in seconds. So let's just see if we can kind of help ourselves out with units. It's going to take it over to feet. Let's just see here. So we're feet squared versus seconds. Yeah. So it really doesn't help us by changing units there. All right, so we got to update this one as well. So we got from seconds, we got to go to hours. So let's see here. So we have it in hours. So 0.012 is in hours. So we'll multiply by 3600 to get over to seconds. Nope, to get there. 0.012. It's in per hour, so we need to divide by 3600. Yep. All right, so we got. So 3.33 10 to the minus 6. All right, so let's see. We're going to go 3.333 e to the minus 6. Looks good. So it takes the e value there. Ambient temperature is 10 degrees Fahrenheit. So we'll type that in there. All right, so I think we're all good with that one. All right, so let's go to convection again. And now it's on interior surfaces. So hold down Control. Click all those surfaces, and we'll click Apply. Come down here. Oh, I gotta fix that one. So the interior H is 0.037. That's per hour. So we're gonna go to seconds. So divide by 3600. So 1.02. Now let's just copy this guy. So come down here and paste. Let me get rid of some of those sevens. All right, and then ambient temperature is 140 degrees Fahrenheit. And that looks good. Right, so let's come back up here to mesh. And let's see what we get. So we'll just run first mesh, see what it looks like coarse-wise. Yeah, so that's pretty coarse here. Let's see what the statistics show us here. Can't go over, oops. Can't go over 256K nodes, so we're okay there. So let's relevant center, let's go to Find here and update. See what we get here on the mesh. All right, so that's better, 190. So we're not over. Still not great. I mean, I mean, probably good overall for in the center, but if we have some strong gradients, we're going to want to refine that a little bit more. But let's run this for what we have right now. So we'll go ahead and go to Solution, and we'll want the thermal plot, so we might as well just get that now. So I'll come in here and get the temperature plot, and let's go ahead and solve it. So what I did right there is I just right-clicked on temperature and clicked on Solve. All right, so you can see what it looks like there. It's right on the XY surface. So working outward there from a min near 20 to a max near 124. So again, we have convection. So the air temperature out here is 10 degrees Fahrenheit. And in here it's 140 degrees Fahrenheit, but not actually at the surface. So it makes sense that the max and the min are a little bit higher or lower and higher respectively from the other ones.